Now you can hear me. Awesome. Well, thank you for having me. For those of you who don't know me, my name is Mark Jensen. I work at Kubrick. I'm an ontologist at Kubrick. And before that, I was working at UB in various contexts as a researcher and as a graduate student with Barry, Allen, Alexander Deal, Werner, in a variety of different contexts over the years. I'm one of the developers of the Common Core ontologies. Today in my talk, I'm going to cover some of the same ground that Alan did to a certain extent, although in a very different way. I want to introduce you to this class that we have called stasis, which is specifically designed to represent some of these temporal challenges. I'm going to go through some of the problems with the current iteration of that and go over some of the use cases of the class and some of the modeling scenarios and propose some solutions to address those problems. So just briefly, the Common Core ontologies have been under development primarily by Kubrick since 2010. They're fairly widely used across the DoD and a bunch of other government agencies, as well as some private companies. The Common Core itself is typically not directly supported. The development of it isn't typically directly supported. Mostly we develop domain extensions and application ontologies. And as a result of that, the mid-level of the Common Core is kind of percolated up to the top. In many ways, it's a labor of love by the people who are involved in developing it. It's composed of 12 is going to be composed of 12 at least partially interdependent ontologies. For example, we have ontologies for artifacts and events and information entities, geospatial entities, and time. It's publicly available on GitHub, and it's playing a central role in the development of an ontology foundry for the Department of Defense and the intelligence community. And it's also in the process of going through a standardization process with the IEEE. So, what is stasis? Stasis is a class for representing processes wherein some aspect of a continuant is unchanging for the duration of the stasis. The class provides us a way to represent temporal data for things like an independent continuant bearing a specifically dependent continuant, or perhaps carrying a generically dependent continuant for a particular time, as well as degrees or intensities of specifically dependent continuants. Stases are not used for snapshots. There's other processes that we can time index and associate them with measurements and descriptions and so forth. They're also not used for representing complex configurations, states of affairs, things that may or may not obtain. So some examples of stases of specifically dependent continuants. We might have this need to find out how many weapon launchers were operational during a staging phase, or the number of employees that were employees at a particular organization for all of 2022. We might be concerned about what documents were contained on a computer during an act of international travel, or saying something like the skin near your third finger was protruding during an exam. Examples of stases of degrees. We talk about the temperature being within a particular range. The RPM of an engine exceeding a threshold during the segment of a flight. We have data about a fleet of aircraft. Part of that data has to do with their capability to perform a particular mission. Or the gap between a turbine blade and the turbine housing, and knowing that it was nominal during a power surge event. So, the original definition for stasis, maybe not the original, but the one that was used for quite a while, a process in which some independent continuant endures and one or more of the dependent entities it bears does not change in kind or intensity. Now, users of the Common Core I can't remember when it went up on GitHub, I guess around 2016, as our user community grew and became open sourced. Said that they were using stases in other ways. And in particular, one use case was for relations, stases of relations, parthood, location, and so forth. And so we changed the definition to be less restrictive. It's simply one in which one or more independent continuants endures in an unchanging condition. So we can't have an ontology talk without a screenshot from Protégé. So those are the classes, the hierarchy of some of the various stases in the Common Core. This is what's in the Common Core, which is the mid-level, the publicly available version, but there are many more specific stases in the domain extensions, which are not public. Yes, marriage is a stasis. One thing I like about this screenshot is it puts process profile at top and process boundary at the bottom, although you can't see it, because stasis has a lot in common with these kind of somewhat odd processes. All right, so, but there's problems here, right? This new definition is kind of vague and it seems very overly inclusive. Some criticisms said we need to go back to making it clear that it's an aspect of the independent continuant that's not changing, because it seems to be incoherent to say that an independent continuant's not changing. Is that better? Oh, you bringing me another microphone?
If you want.
What?
If you want to.
So I don't have to hold this?
If you want to connect it up here.
Man. All right.
Let's see how.
How's that? Is that better? No, I had it underneath my. How's that? How's that? How's that? How about I just hold this? It's lighter. It's lighter than this. All right, so this was the suggestion, and in fact, I think Alan was the one who suggested this, because Alan was tasked at one point with reviewing a bunch of the stuff in the Common Core when we were going through a different standardization process about 2 years ago with Insights, standardizing what a mid-level ontology is and making the Common Core an exemplar of that, similar to what BFO did with the ISO process I went through. We have a lot of different users of stasis, and they're being used in a lot of different ways. And there's no clear articulable pattern for which it's being used. So there's integration challenges when a bunch of ontologies within the same ecosystem are trying to use this class in all the different ways it's being axiomatized and so forth. And right now, there's no clear way to use it for asserting the duration of a particular relational configuration between two entities. So now maybe this is a feature, right? Sort of a ontological mulligan, right? Do whatever you want with stasis. You can have one freebie to solve problems for you when you're modeling data. There's more problems, and as Alan spoke to a good extent in his talk, there's this ontological problem about process types and understanding what the extent of a process is. How do we distinguish them? There seems to be spatiotemporal considerations, participation, and parthood that all play a role. But nonetheless, we have this problem with understanding what the spatiotemporal extent of an unchanging color or size of a rash. Another problem. You're killing me. You're really. How's that? How's that? How's that? I got a floppy collar. Is that better though? Yeah. Can you hear me, David? Can you hear me, David?
Yes, I can hear you.
Thanks for the thumbs up. All right, so I've used this myself in talks, talking to people, that things like profiles and stases are thin processes. They have thin temporal slices, but no real spatial extent, but I really don't know what that means. All right, so I made an attempt to really restrict stasis and come up with this definition that required it to be part of the history of an independent continuant that has a bearer that's not changing. But as I pointed out, this is not amenable to relational stases, and that we run into this problem that histories don't work for immaterial entities. Sites certainly can bear things like lengths and volumes and so forth. So it was a failure. All right, so let's just reset a little bit. Using OWL, we want a way to model temporal data for portions of reality that do not have a clear processual component with them, associated with them. And we want to have a straightforward pattern using symmetric triples and RDF to do so. Independent continuants that bear or carry some dependent continuant during an interval, having a duration associated with it. An SDC that has a degree, a particular temperature, particular shape, particular color. And it seems as though we want to have we have this desire to do relational stases, have two continuants existing in a stasis where they're related during that time, related in the same way. And a last use case, which is highlighted because I really haven't had a chance to get into this yet, but it's certainly worth talking about, is that using stasis and perhaps other terms to provide a temporal interpretation for an ontology that doesn't use temporalized relations. Two independent challenges. One has to do with this notion of degrees of dependence or valued types, as I just mentioned. And then this challenge of representing durations of entity where it exists as in an unchanging condition, such that I don't know. That's, see, I didn't have time to finish my slides. Whoops. Okay. So moving towards a solution, after thinking about this a lot and talking quite a bit in the last few weeks, what I see is that both of these problems, not those problems, but we have two basic patterns with respect to the second bullet before, which is how to address this representational challenge, is that they're both relational. In the case of dependent relationships, such as bearer of, we really don't need to do anything other than exert the existence of the dependent. But in non-dependent relationships, such as location of, we need to link the two continuants together and somehow identify that that relationship can be given in a way that can be given a temporal interpretation. So, in the next few slides, I'm going to use the term degree of dependent to refer to an SDC which determines the specifically dependent that it depends on. This is essentially a valued type. It's very analogous to what OBI is doing, except they don't, I think it's analogous to what OBI is doing, but they don't actually create a type of SDC. They have the valued type, the information specifically be just about the bare temperature, the bare quality, if you'll allow me that phrase. This solution would also require using BFO 2020's object property exists at, which is a relation between a particular and some temporal region at which the particular exists. So I'm contending that this unchanging aspect is not directly of the independent continuant, of course, but it should always be one of the dependent entity. It's an unchanging aspect of the dependent entity. And what doesn't change is the type of that dependent. That's what we mean. Some examples. David's employee role. He was employed at Kubrick during the last fiscal quarter of 2022. His role exists during that temporal interval. And it exists as that employee role. It can't be anything else. And these are just some sparkly pseudo triples. It doesn't really matter. There's a diagram for it. It's a big one. He has a role, it adheres in him, and that role exists at a temporal region, and we can designate it, we can measure it. In this case, it's designated by this sort of standardized way about talking about fiscal quarters. This designator is an instance of information content. In the degree case, Hilda's normal temperature Same idea, roughly, except that we have another dependent, which is described by an ICE, and that exists at a temporal region. That degree does not change during that temporal region. It's always normal. Now, what's normal? Well, there's some other bits to this graph. Normal is prescribed by some directive, by some standard. What does it mean to be within a normal temperature range? Could be specific to an organization, the AMA, the WHO, it doesn't matter. We have ways of representing that. We can deal with thresholds and ranges.
Yeah, hold on, can you go back? So can you point to where stasis idea is in this slide, please?
There is no stasis here, right? I'm saying we don't need stasis for this case, for dependent relationships like bearer of. Right? So in both of these cases, we don't need a stasis of role because we can just say it exists. It can't be anything else. What's not changing is David's role as an employee during that fiscal quarter. Now, this is a workshop. I should have brought my hard hat. I mean, this is open for debate. This is what I'm thinking. So I want to hear reasons why we need a process for this, like stasis, a process which is contentious. It has problems. Now, same with this, but this is contentious too. So, in a contentious mood. All right. So, the relational model, the second bullet, we have what I'm calling a non-dependent relationship, parthood. A turbine, a low-pressure turbine unit is part of an engine for a 15-month period, right? And anyone who's worked with maintenance data and fleet data has seen stuff like this stuff before. What exists is the configuration, the parthood configuration. So we can leverage stasis, right? It's a stasis of parthood, and it occurs at a temporal region. Or we can come up with another dependent entity that exists during that interval, and then we're back to the first use case, right? Where you're just saying that the dependent entity exists. Because that dependent entity, if it exists, it's the same type. And so there's the pattern for that. Spool is part of the turbojet. They're both participating in a stasis, occurs on a region, and we can measure it 15 months. Now, because these two participants can stand in all kinds of relationships to each other, we need a way of identifying the particular relationship it's a stasis of. And there's two ways to do that. One is to create all kinds of stasis. Stasis of parthood, stasis of location, stasis of being about something. Or we can do something else. We can do something more syntactical. We can just